of x is equal to the expected value of x squared minus the expected value of x all squared. So the next thing to do is just to substitute these values here and also substitute this here. So by substitution, we have our variance of x to be equal to, we bring this out, n p plus n into n minus 1 p squared minus np all squared, which is the same thing as np plus n into n minus 1 p squared minus n squared p squared. Of course, we can open this bracket to give us np plus n squared minus n p squared minus n squared p squared. So this can be continued this other side. We can continue it, or we write our variance of x to be equal to np. If you bring out this, we have n squared p squared minus np minus n squared p squared. Of course, if you want that, the whole of this will cancel the whole of this. So we move over to this other side. To write our variance. For more on this topic, you need to subscribe to this channel. So how do we write our variance? Our variance now, our variance of x will be equal to np we have np minus np squared. This is because when we open this bracket, we got this, and the whole of this will cancel the whole of this. So we are left with np minus np squared, which is this. Of course, you know something is common. So we have np can come out to give us 1 minus p. Of course, from probability, q plus p is equal to 1. It then implies that q is equal to 1 minus p. So it then means that our variance of x is equal to np q. That means that our variance of x is equal to np q. So this is how to obtain the characteristics function for the binomial distribution. We have our expected value of x to be np. We have our expected value of x squared to be np plus n into n minus 1 into multiplied by p squared. And we have the variance to be np squared for that of the binomial distribution. For more on this topic, you need to subscribe to this channel.